So we're given the velocity of air through the trachea depends on lowercase r, and that is kr squared times big R minus lower r. So big R and k are constants. Okay, so because I want to find the greatest velocity through the trachea, I want to find the derivative. So I want to maximize the velocity. So I'm going to take the derivative with respect to lowercase r. So this, I'm going to have to apply the product rule. So if I take the derivative of kr squared, that's just going to be 2kr. And then multiply that by big R minus lower r. Plus, now we're going to take the derivative of big R minus little r. So big R derivative is 0 because it's a constant. And then the derivative of negative lower r is negative 1. Multiply that by kr squared. So I'm going to simplify this. They both have a kr factor. So I'm going to pull that out. I'm left with 2 times big R minus lower r minus r. And I guess I could go a step further. So if 2, I can distribute the 2, so it would be 2 times big R, 2 times little r minus r, which is 2 times big R minus 3r. Okay, so that's the velocity, the derivative of the velocity. In order to maximize it, you want to find the critical points. So we're going to set the derivative equal to 0. So in other words, k times r multiplied by 2 times big R minus little r is 0. We're going to set each factor equal to 0, so k times little r, and 2 times big R minus 3 times little r. We get r is 0, and it is 2r over 3. So we want to see which one is going to be bigger. So we have to classify the critical points. But you could probably guess that radius of 0 is not going to be the answer. So let's take a look. You can't have anything a radius less than 0. That does not make any sense. So we're going to put 0 on the left here. And then we have 2 times big R over 3. So we want to pick a point between 0 and 2r over 3. So let's just pick big R over 3. And then let's plug it into our derivative. So if I plug in v prime, so if I have v prime of big R over 3, so it's k times big R over 3 is 2 times big R minus 3 times big R over 3, which is just big R. The 3's will cancel. And so I get kr squared over 3. So that's positive, right? Because big R is a constant. It is positive. So same thing with k. Now we want to pick a value to the right of 2r over 3. Let's say this is big R. Halfway between this is, let's do 5/6 over r, right? So think of this as 6r over 6. Think of this as 4r over 6. So the halfway point is a good value to plug in. We're going to plug that into our derivative now. So it's k times 5 times big R over 6. And then we're going to multiply that by 2 times big R minus 3 times 5/6 big R. So that is 5k big R over 6. And that's 2r minus 15 over 6 big R. So let's see, 2r minus 15 over 6r, that's the same thing as 12r over 6 minus 15r over 6, which is negative 3r6. Multiply that by 5k big R over 6. And so we get negative 15k big R squared over 36, We don't have to go further. This is negative. So clearly, the velocity of air is increasing and then decreasing. So that makes lowercase r equal to 2 times big R over 3 a maximum. And that is our answer.